Modern data volume is accelerating rapidly. We are routinely seeing these systems swell into the petabyte range, and when you hit that scale, traditional querying methods completely break down. Look at this trend. The data volume spikes exponentially, while the engineering headcount meant to manage it stays flat. You cannot hire your way out of this math. To survive this imbalance, you have to stop the database engine from scanning your entire dataset every time someone runs a query. That makes partitioning a mandatory architectural requirement. This graphic illustrates exactly what partitioning is. You are taking a massive, unwieldy table and physically dividing it into smaller, logically separated parts, so the engine only looks at what it actually needs. Everyone now has to partition at scale, but the specific method you choose to execute this split dictates exactly how your team's engineering hours are spent. For years, we relied entirely on manual partitioning. Your engineers dictate every single aspect of how the data is organized and stored. Now, look at this title panel. We are comparing that traditional approach against the modern alternative, hidden partitioning, where the database engine invisibly handles the organization for you. You are trading absolute granular control over your data structures for a drastic reduction in maintenance overhead. So is relinquishing that structural control to an automated engine worth the engineering hours saved? Or do your workloads demand manual predictability? This is a strategic decision about resource allocation and technology lock-in. Building this manually requires serious upfront analysis. An engineer has to study the specific usage patterns of the data and manually select a partition key that makes sense for how the business operates. This panel highlights the execution. See the yellow SQL code? Developers write specific table creation logic, defining these partitions by date. Here is the result. Data is neatly filed into visible chunks, like these month folders, giving the database an explicit map. But when usage patterns inevitably change, or a new month rolls around, your team has to step back in. They are physically creating and maintaining those new partitions over time. You get absolute predictability, but you buy it by taking on a permanent time debt for your engineering team. Hidden partitioning removes the engineer from that process entirely. You simply ingest the data, and the engine takes over. Looking at the hidden partitioning panel here, you can see these green internal micropartitions. These are complex structures the engine automatically generates to organize ingested data without any user prompting. Instead of following a user-defined partition key, the engine creates its own internal metadata to track exactly where everything lives. Your maintenance overhead drops to zero. However, the entire process becomes a black box. You cannot see, access, or tweak those underlying partitions. It automates efficiency, but it forces you to implicitly trust a proprietary algorithm over your own team's logic. This compares query execution for March 15th data. Manually, the query checks the defined key and scans only the March folder. On the hidden path, the engine cross-references internal metadata, automatically pruning irrelevant blocks to isolate specific micropartitions. Both paths successfully achieve the exact same goal. They drastically reduce the amount of data scanned. They just utilize completely different operational mechanics to get there. Manual partitioning works out of the box on almost any traditional SQL database. Hidden partitioning, on the other hand, requires specialized modern infrastructure. This graphic answers where hidden partitioning is actually used. It is native to major cloud platforms like Snowflake, Databricks, and BigQuery. Adopting this hidden architecture means fully committing your data pipeline to one of these proprietary platforms. You gain the luxury of automated query pruning, but you pay for it by getting locked into a specific vendor's ecosystem and their corresponding pricing model. This scorecard outlines key differences across 3 metrics. First, control. Manual requires user-defined keys, while hidden decides internally. Second, maintenance. Manual demands ongoing upkeep, whereas hidden is automatic. Finally, visibility. Manual partitions are visible, while hidden structures remain entirely obscured. More control equals more work. Less work requires relying heavily on automation. The right choice comes down to your specific organizational constraints. Manual partitioning is for traditional database administrators and teams locked into legacy on-premise servers or standard relational databases like Postgres. If your workloads require absolute granular control over storage, or if migrating to a premium cloud warehouse simply isn't in the budget, you stick with manual. Hidden partitioning is built for modern data engineering teams prioritizing massive scalability using platforms like Snowflake or BigQuery. It empowers analysts to query freely without breaking systems, and it removes the recurring cycle of manual partition creation and cleanup from your engineering roadmap. Choose manual if your architecture demands strict control over how every byte is stored. But if your goal is faster query speed and maximizing the time your engineers spend on modeling rather than maintenance, hidden partitioning is the logical path forward.